Hello everyone and welcome back to the Circle Military Frequency. It may come as a surprise, but helicopters can routinely and safely land on the flight deck of smaller ships in severe seas, even when the ship is not only moving, but also rolling from side to side. Despite the fact that there is very little room for error, the landing is easier than you may believe due to the bear trap. However, sometimes things can go wrong, which is why there are some conventional emergency protocols for helicopters unable to land on the deck of a ship. Wind velocity, ship motion, and sea conditions all influence helo landings at sea. Additionally, the air weight generated by a ship's superstructure might affect helicopter performance. These parameters and others are incorporated into Ship Helicopter Operating Limits, or SHOL or SHOL. SAOL is a polar plot showing permissible conditions under which it is regarded safe to conduct flying operations. Staying within these operational parameters should allow a helicopter to land safely. In the past, however, landing a helicopter in rough waves was regarded to be outside of its operational parameters and hence was not a common practice. After the Canadian success with the bear trap, other fleets, including the Royal Navy and the United States Navy, adopted comparable technologies. This is how a Canadian bear trap operates. Attached to a cable that is lowered from the helicopter to the flight deck is a probe. The flight deck crew then hooks the rope through the center of the bear trap to a winch underneath the flight deck using bare hands. This aligns the ship and the helicopter. When the pilot and landing signal officer are satisfied that the helicopter and ship are moving pretty steadily, the pilot reduces power and the LSO raises cable tension. As the pilot descends, the inch pulls the primary probe of the helicopter into the center of the bear trap, which is then closed. Therefore, more complex variants of the bear trap, such as Curtiss Advanced Rights Handling Technology, known as ASIST, were created. ASIST employs an optical positioning system that continuously tracks and monitors the helicopter's precise location relative to the chosen landing zone. As soon as the helicopter lands, it is quickly secured using the bear trap, aligned, and traversed into the hangar without the need for humans on deck. The advantage of this technology is that no employees are required to approach the helicopter, even in stormy seas. In the 1970s, a variation of the deck lock system with a harpoon mechanism was developed in the United Kingdom and tested on this mobile platform. This system's ability to rotate the helicopter through 360 degrees facilitates its operation. Bear trap and other similar systems have strategic significance for smaller surface fighters that rely on helicopters. In 2017, Japan created the first device capable of automatically landing a helicopter on a moving ship. This technology utilizes GPS navigation to approach a ship. Then the laser sensors on both vessels are engaged to calculate the helicopter's relative position to the moving ship with an error range of just a few inches. This allows the helicopter to land autonomously and safely. The first option besides landing on the ship is to land somewhere. Obviously, this is not always practicable, but since helicopters may be refueled from the ship while in flight, the refueling can boost the helicopter's range to its maximum, which in some instances can provide an alternative landing location elsewhere. Helicopter in-flight refueling, or HIFR, begins when a bag tied to a cable is lowered from the helicopter onto the flight deck. The team then connects the fuel pipe to the rope, which is hauled back onto the helicopter and attached to the fuel tank. After fueling is complete, the hose is retracted and the helicopter takes off. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content.